Hi everyone. In this presentation we'll be talking about workflows, standards, and tools that allow you to capture records stored inside relational databases and archive them in a long-term digital repository. So we should start by talking about how records are stored in a producer system, or in the system where someone actually creates those records. And the scenario is, so we have records somewhere in the institution that actually created those records, and we want to move them, transfer them to the archive for long-term archival. So we thought about three different scenarios. You might have records on the file system, let's say Word documents and PDFs with digital signatures. You might have some metadata close to those records, or you may not. You could very easily find scenarios where you have the folder name where those files sit be the only metadata that you have. The second scenario is where you have actually a very complex and advanced electronic record management system with workflows, with custom metadata, with classification plans and all of those things. And that is actually the system that is used to create the records, provide workflow engines that allow you to move those records around the people that need to access them, and then it has implemented rules on when to discard those records or when to transfer them to the archive. And then you have a third scenario, which is where you have a relational database where you actually keep the records, and those records are the ones that you want to preserve and to archive. So this is really the focus of this presentation. We'll be talking just about archiving records that sit on relational databases. But giving a step back, so why do we actually archive databases? Why do we need that? And there are a lot of reasons for that. I mean, databases currently hold a lot of important information. They support most organizations' internal information systems. They hold interactions between the public sector and the taxpayers, which is really important for transparency in the public sector. We probably want to keep those and to provide access to those records. They actually keep day-to-day business activities. They record everything that goes on an organization, depending on the system that's sitting on top of that. Sometimes relational databases hold scientific data, so we shouldn't expect all scientific data to be on a triple store or in CSV files. Sometimes they are in relational databases, and that's something really important that we want to archive. And there's also the case where records actually do not exist in any other form. They just sit on a relational database. They are staying there, and we need to preserve those records as they are. There are also legal and historical or heritage reasons. Some countries have legislation that mandates that databases are periodically archived. There might be some financial reasons as well, because keeping a live database has probably high maintenance costs, and there are definitely license fees that you have to pay if you want to keep those records accessible in the original relational database management system. Also, if you think about archiving an entire database, if you think about the practicality of the thing, it's really an efficient way to preserve a large number of records. There's little manual effort involved in extracting and archiving those records. Whereas if you want to preserve each of these individual records with all the metadata and all the complexity that you might want to collect, that would be a lot of more effort to put into that work. But if you think of it, storing or archiving an entire database is not really so much different than keeping a parish record book. So if you look at this historical 1600s parish record book of baptisms, you see that there are 2 records here. And in a modern record book, you would have 2 records on the database. So it's essentially the same thing. It's just the object moved from an analog form to a digital form. So if you want to archive a database, what would be the typical workflow? Let me just start with a scenario. So let's say that you have a database that has been in use for 15 years at your given organization. Imagine that this database just holds information about, I don't know, some kind of business process, and that business process has been decommissioned. I mean, the organization changed over time, and that particular business process is no longer in use or in practice. However, there is an interest in maintaining that data for legal and accountability reasons. Let's say that it just holds, for example, financial records from a department that no longer exists. So because of that, we have selected this database for long-term archival. So what we do? So imagine you have the database, you have identified the database. So you need some kind of tool that could tap into that database, extract the data that you want, and store it in some kind of archival format. Okay, this is really the object that we want to preserve in the long-term archive. Before sending this to the repository for long-term archival, we need to package it somehow into a submission information package that the repository is going to accept. In that package, we probably would add some metadata to describe the database and to provide more information about the producer and some other diplomatic properties that for archival reasons are relevant. Once we have this submission information package with the archival format of the database inside, we can send it to the repository for long-term archival. So let's just imagine that years later a user wants to access the data that we just archived. So this is our user. In order to find the database that she wants to access, she would just use the discovery services provided by the repository. She would just query, send some terms, find the database. Once she finds the database, she would request a dissemination information package, which could then be handed over to some kind of access component that would explode that dissemination information package, and it would provide you, I don't know, services to access the data within that dissemination information package. So of course, remember, we archive the database as an entire block of information. So this access component is really important because it will allow you to navigate through the records in that entire mass of information. Okay, but the user just doesn't want just to view the data or to navigate over the entire relational database. She wants to create some more advanced queries and analysis on the data. So she would probably go through the same process of finding out where the database is located. She would then download the archival format. She could take that format and transform it using some kind of data transformation ingest or ingest tool, transform that archival format into a live relational database, which she, because she's an advanced user, could use to, I don't know, provide some or make some advanced SQL operations, or maybe do some OLAP operations and analysis over the existing data. So if we actually manage to do this, I'm assuming that the IT department would be very happy because they no longer have to maintain dozens of legacy databases. And of course, the management of the organization will also be very happy because the costs have been reduced. You no longer have to maintain these high cost license fees and maintenance and so forth. So let's talk about tools and formats. How can we actually accomplish this workflow? And I'm going to show you a few tools, actually 4 different tools and 1 preservation format to actually implement this workflow that I just explained. And I'll start with the format. So what is this format? What is this SIARD format? It's basically a vendor-independent database preservation format. It has been developed originally by the Swiss Federal Archives. The SIARD name stands for Software Independent Archiving of Relational Databases. It's based on international standards such as Unicode, XML, SQL 2008, and URI. And it has been an e-government standard in Switzerland since 2013. In this project that we are involved, we actually worked on creating a second version of SIARD. This has been a joint effort from the Swiss Federal Archives. They were the original authors of SIARD 1, and also people from the eArc project and the e-government standards in Switzerland as well. This new version combines the best features from SIARD, from SIARD-DK, which is a variant that is in use in Denmark, DBML, and ADDML as well, which is a format used in Norway. So what's new in this SIARD 2? So we've upgraded from SQL 99 to SQL 2008. So we have new types in there. So we basically are able to cope with more recent database types that SIARD 1 could not cope with. There are more explicit validation rules for some data types. We use regular expressions for that. There is a small modification in definition that shows when to store large objects inline as part of the XML table, or where you want to extract them and put them in outside the XML table. This already kind of unveils the fact that the data is actually stored into XML. The standardization process is going on in Switzerland mostly. So now I want to talk about the Database Preservation Toolkit. This is an extraction tool. This is actually the tool that taps into the relational database and selects and extracts the entire database to the preservation format. It supports various output formats, but SIARD 2 is actually the default preservation format at the moment. It is compatible with Oracle, Microsoft SQL Server, MySQL, Postgres, and Access, Microsoft Access. You can support other database engines if they actually provide a driver for JDBC. It's actually a multi-platform tool. It's a command line tool because you probably want to run it on a headless server, which means that you probably won't have a user interface to actually run the command and do the export. And because it's multi-platform, it's made in Java, you can run it on Windows, Mac OS, and you can run it on Linux as well. So the tool also provides support for large text and binary objects. So if you have large objects or blobs in your relational database, the tool will be able to extract those and put them inside SIARD, or optionally outside the SIARD file if you want. There's an option for that. The tool also supports extracting views, triggers, store procedures, and user-defined types. Most of them are behavior aspects, which means that we don't actually convert them into a normalized format, or we don't even convert those into, let's say, if you have a store procedure in Oracle and we want to convert that database into SIARD and then from SIARD to MySQL, we won't be converting those store procedures. So the behavior aspects of the database are documented, they are stored inside the SIARD, but they are not transformed. So you cannot actually operate with those. In terms of performance, the tool is very lightweight. We've done some tests, and it's able to do something around 4,000 records per second on a large text database. So it's not just very simple records, it's actually some KB kilobyte size records, and it's able to do about 4,000 records a second. In terms of memory usage, usually it stays around 200 megabytes. If it has to cope with large binary objects, then this will grow a bit, but it's very efficient. This is really how it works. So we have import modules, we have a intermediate data representation layer, and we have export modules. And you can combine any type of import module and any type of export module. So you could easily configure a route between MySQL and SIARD2, or Postgres and Oracle, for example. Any combination of import modules and export modules can be done. So now that you have your archival format for your database, now you have to package it. You have to transform that into a SIP, or submission information package, so that you are able to send it to the repository. And for that we have the RODA-in tool. It's a tool that is compatible with the eArc zip format, and it has been designed to create 1,000 or thousands of SIPs with just a few clicks. These SIPs can be gigabyte size, so it's the ideal tool to take your archival format that you just created using the Database Preservation Toolkit, package it as a zip, and send it to the repository. This is just a few screenshots of the tool. So you have your file explorer on the left, you have your SIPs on the middle, and you have the ability to provide some metadata, descriptive metadata, to package that and send it to the repository. Now that we have an SIP, we need a repository, and this is where RODA comes in. RODA is basically an open source digital repository. So it's vendor free. You don't have any licensing costs. It's actually a turnkey solution, so it's ready to be used by archivists, producer, and consumers. You don't have to do a lot of configuration to have the system going. It has preservation and authenticity in mind since its original creation in 2008. We're actually now developing or releasing version 2 later this year. And when we mean about preservation and authenticity, it's just it has functionality for example, generating and keeping preservation metadata. It has embedded preservation actions, so you can actually run preservation actions on your data. And it has a built-in risk management feature that allows you to document all the decisions that you have made. It's a bit like preservation planning, but on a risk management level. So main features: user-friendly design, configure a storage system. We now support raw file system, and we support Fedora 4. It has a blazing fast search engine because it's supported by horizontally scalable technologies. We can actually spread the search engine through various servers so you to have like millisecond responses. We support custom descriptive metadata, so any kind of metadata that you have, as long as you have a schema and it's XML based, we support it. And it supports various SIP formats. The ones I'm particularly interested here is the eArc format. So this is just a couple of screenshots from the tool. This is the ingest process, where you can actually see all the ingest batches that went well and the ones that failed. You have a search capability. All the attributes that you search for are customizable. This is the AIP page where you see all the metadata, and you can actually access the representations. This is the premise events metadata. You can download the premise version as well. This is the visualization tool for an image actually, and this is the risk register interface. So now you have your database in the archive. So now we want to see it, we want to access it. So we've created, or we're actually still developing a toolkit, or a database visualization toolkit. It's basically a web application that It allows you to take these SIARD files and expose them as a nice web application so that a common user can actually view and navigate on the relational database. It's able to cope with millions of records because it's supported by NoSQL technologies that actually scale horizontally pretty well. So you can, in one viewer, you can have several databases with millions of records. However, because it's based on NoSQL technologies, you cannot actually query in SQL. So you have to rely on the UI to do all the navigation and filtering for you. So what it does, it gives you a quick glance on the contents of the SIARD file. Okay, you can see the database structure, you can see what users the database had, triggers, store procedures, everything. You can search and filter, you can hide columns that you don't want to see, you can do ands, ors, nots, exact phrases. All the things that you are used to do on, let's say, Google, you could actually do over the records on a database. We're also developing an export functionality so that you can actually filter your data and then export it to CSV or even PDF. This is how the viewer looks like. So you have, for example, information about the database. This is something that is stored inside the SIARD file. It's kind of like a description of the database that you are just going to see. And then you have the table contents and you have a search box. You can have advanced search, of course. So if you go back and revisit the database archival workflow, so what you would do is you'd have the database, you take the preservation toolkit, database preservation toolkit to generate the SIARD file, you take the RADA-in tool to create a submission information package, and you send it to the repository for preservation. If years later the user wants to access the data, it just searches the repository, finds the right EIP, gets the dissemination information package, can visualize it on the Database Visualization Toolkit, or it could just use download the SIARD file and use the Database Preservation Toolkit to ingest the data back into a relational database, more modern one, and do some kind of a lab analysis on top of that. So just to wrap up, we have now standards and tools available. They are still in beta versions. They will be released final versions towards the end of the year. Documentation, source code, everything is published on GitHub. You will find examples, video tutorials, Docker containers that will allow you to run the repository just with a few clicks. Everything is very simple to use, and you'll find all the information you need on this website. So it's database-preservation.com. So if you have any questions, feel free to contact us through the website.